May I now call to the podium our next speaker, Dr. Michalis Michaelides, Assistant Professor at the Cyprus University of Technology. He's going to speak to us about steaming, a digital way forward to promote port-to-port efficiency. Dr. Michaelides?
Good morning, and thank you for this invitation to the Cyprus Shipping Chamber and the opportunity to share with you the results of the STEAM project. Now, I come from academia. I'm an assistant professor at the Department of Electrical Engineering, Computer Engineering and Informatics at the Cyprus University of Technology. And what I will be presenting is mostly my experiences from the STEAM project and some main results related to the digital transformation of the maritime industry, which is the main topic of this conference. So the STEAM project, the acronym is for Sea Traffic Management in the Eastern Mediterranean, and it's an integrated project that started on January 2019 with a duration of 3.5 years. So we recently finished the project last June, a funding amount of €1 million that was given by the European Regional Development Fund and the Republic of Cyprus. Now, the main motivation, the main objective behind the STEAM project was to develop the port of Limassol to become a world-class transshipment and information hub in the Eastern Mediterranean area, adapting modern digital technologies brought to the maritime sector, and also a driver for short sea shipping in the Eastern Mediterranean area through the enhanced services and standardized ship and port connectivity. The main objectives, the general objective is the efficient management of the sea traffic, while at the same time ensuring safety and environmental sustainability. And this was achieved through 5 major pillars. The first had to do with improving the efficiency of the various port operations. And here we employed the Port Collaborative Decision-Making Platform, the Port CDM. The second was to optimize the sea traffic navigation and facilitate short sea shipping in the area. And here we tested some services coming from the Limassol Shore Center that was implemented through the VTS at the Port of Limassol. The third was to collect real-time information related to ship movements, the environment, and the tracking of cargo. The fourth was to have high-quality data, calculate KPIs, and also create some new decision support tools for the users. And the fifth was to develop effective links and synergies among all interested maritime stakeholders. This had to be a group effort, so everybody had to be involved. So the fifth task was implemented, the fifth objective, through a number of living labs that took place at the Port of Limassol, where everybody was invited to exchange ideas and discuss the implementation of the project. So like I said, the consortium, we had research and academic institutions involved. Except CUT, there was the RISE from Sweden. We had the Cyprus Port Authority. We had the Cyprus Shipping Association, and also from the private sector, we had CSCS, Delevan, and Tototheo. And it was all kicked off February 2019. We also put together an associated stakeholder network with major players, with all the private companies at the Port of Limassol, DP World, Eurogate, and P&O Maritime. Also, Cyprus Shipping Chamber was an important participant in this network, as well as Marinem. And last but not least, we had an advisory group from international stakeholders who were involved in the international maritime sector from different ports and different maritime authorities. I have to say that our interest in the STEAM project and how it all started was our involvement in the previous project, this Sea Traffic Management STM validation project, which you probably know about because I remember we gave a presentation in an earlier, a few years ago in this group. But this sea traffic management validation was a very large-scale project with over 50 partners run between 2015 and 2018 in 9 ports in Europe, one of which was the port of Limassol. And at the port of Limassol, we were able to validate concepts like the port collaborative decision-making platform, as well as voyage management services. So our goal, again, in this project was to ensure efficiency, safety, and environmental sustainability. And the way we did that, I mean, the driving force behind that was to increase the number of interconnected devices. So here comes the digital transformation. And also, we wanted to mature these big data analytics platforms that were used for different types of data. So in the very end, we wanted to create this new intelligent data-driven application and develop these specific services that had to do with the problem at hand. And we also published a survey in the Internet of Things journal that is listed below that basically discusses about this new concept of Internet of Ships and looks into the future and all the digital applications that are related to this. So what is data when we are talking about the STEAM project, and where does data come from? Because, as well said by the previous speakers, you cannot go digital without having the data in the first place. So when we talk about data, we're considering 3 primary sources of data: AIS data, port call data, and environmental data. This didn't work very well. So on top of this, we have the STEAM platform that integrates everything. And so we're able to build these data-driven applications and services that I'm going to discuss in the sequel. About AIS, I don't need to describe it. I'm pretty sure the audience is very familiar with AIS data, and it's a very important source of information. As far as the AIS framework, we didn't just collect AIS data, but we built an intelligence service on top of AIS data. So there are some key challenges associated, like volume and velocity integration, intelligent data cleaning, and online aggregation. We dealt with all of those issues and integrated different types of AIS data from different sources. And we're able to do some cleaning also. And in the end, we built this. Okay, before that, as far as AIS data cleaning, one important contribution of the project was this port destination field that is included in the AIS information. It's a text entry, and usually it's associated with a lot of errors. So we developed an automated method to clean and normalize this dirty port destination data, employing some fuzzy matching. So for example, if the dirty string was Larnaca, which is misspelled, we employed the fuzzy matching rules, and then we got a clean result that was fed into the system, and this could be used directly by machine-to-machine type applications, whereas the first could not. So we were able to do this automatically for all the entries and have a better set of AIS data to use. So this is an example of the cleaning that was performed. So on top, we developed this ship tracking intelligence platform that has all the different data that was collected, the clean data, a bunch of statistics that can be calculated, and also a live map with all the positions of the ships in the area. We also developed some other nice applications on top of using the AIS data. One of them was the AIS safety, which is presented here. So basically the main idea here is to generate real-time alerts for entering or leaving some areas of interest. This could be the anchorage area, this could be the port area, but it could also be an environmental important area that we want to monitor the traffic through. Moreover, we are able to create real-time alerts for potential vessel collisions. So if there is a danger, there is an alert that comes on screen. And this is, for example, a service that would be used by the Limassol Shore Center by the VTS personnel. Now, moving on to port call data, which was the second source of information. The port call process related to the to the activities of arrival, berthing, cargo loading and unloading, shifting anchorage and departure of ships from ports is a very fragmented procedure, a lot of different actors involved with different types of information, and usually there is no real-time synchronization between them. To solve this issue, we propose the use of a MetroMap type solution. So each different color here represents a different actor at the port of Limassol, which is implicated in this process. And each metro stop is an exchange of information between all the relevant actors. So by using this first diagram, we're able to organize the information, and then all this information is fed into a platform, that I'm going to say in the sequel. So the main challenges are the distributed pieces of information and the loosely coupled organizations. There is a strong need for standardized information sharing, real-time situational awareness, and collaborative decision-making, which can be achieved through the Port CDM solution, the Port Collaborative Decision-Making. So this is the current situation at the Port of Limassol with the private companies, and where you see an arrow is an information exchange between the different actors. And this is the solution that we implemented. So we have a Perseus platform, which is a Port CDM platform that integrates all the live data from all the different sources and enables this just-in-time operations and real-time sharing of the port call information. One important functionality of the Perseus data sharing platform is this port-to-port connectivity. So since it's a cloud platform, any port with the right API can communicate to this platform and exchange information. So for example, an upstream port can convey the information about the estimated time of arrival and departure to the downstream port. And this port-to-port communication can seriously enhance the efficiency of the port operations and avoid any delays and so forth. So this is an example of how this port-to-port communication would be established. And I should say that the message format is a standardized. The S211 is the port call message format that was already accepted as a standard format. This port-to-port collaboration can save a lot of, can improve punctuality and efficiency dramatically. And this is just an example from the port of Larnaca, where this was implemented as part of the project. And we can see that the arrival punctuality is always greater than 80% for all different types of vessels. We did also an analysis about short sea shipping and about shipping in the area of the Eastern Mediterranean, because as you know, the port of Limassol has a lot of neighbors that are a short distance away. So it's very important to receive this accurate information ahead of time. So this was also identified as the biggest problem at the port of Limassol when we talked to the local stakeholders, the absence of information from nearby ports, because once a ship was on sail, there was not enough time for the shipping agents to convey this information to the system and provide enough warning to the port. So it was very important for them to develop this idea of port-to-port communication. Like I said, we also concentrated on KPIs. So our partners, Delevant, developed some really nice online analytic Power BI dashboards for different KPIs that can be calculated about the port call. Predictability, punctuality, but all types of different statistics as well. Moreover, they developed a forecast dashboard where you can predict the traffic that is going to come at the port of Limassol over the next days in the future horizon. And this can assist the scheduling at the terminal. So this is also something that we worked on the project, the berth allocation problem and how to do efficient scheduling of all and optimize the seaside operations. In particular, for the berth allocation problem, the problem is to assign berthing positions to arriving vessels at the port in order to minimize total waiting time, handling cost, and late departures. So this is, for example, the data that goes in. There is a berth scheduler, and you get a two-dimensional map at the end of it, time and space, where you place all the different ships according to a schedule. So I won't bore you with the details, but we did a mathematical analysis and solved this using metaheuristic, the cuckoo search algorithm in particular, using real data from the port of Limassol. We also developed, we used various services, and this was done using the TM Synergia from Tototheo, their platform. We had an environmental monitoring plan in place where we monitored the air and water quality in the area of the surrounding the port of Limassol using 2 buoys with a variety of different sensors that measured water pollution parameters. We also employed 2 UAVs, 2 oil detectors, 10 air quality nodes, and a number of different data delivery platforms, both using online data that was available from services like Copernicus that is free, but also the in-situ, combining the in-situ information that we were receiving. So like I said, for the data collection, we monitored a number of different parameters. We collected data, meteorological data, air quality data, and water quality data from different sources. So in this effort, we also integrated data coming from air quality stations of the Department of Labor and Inspection, and also meteorological data coming from the Meteorology Department, together with our own data, and all this was integrated into a common database and shown to the user through our visualization platform. So on this map, you can click on any node and get live measurements of what is going on for the specific parameters. And there is also a coloring that goes with thresholds and levels of pollution that you can see right away if there is a problem in the designated area. As far as environmental monitoring, we took this a step further and did some research on eutrophication, which is a significant environmental problem. And we developed some artificial neural networks to examine the impact of eutrophication-related parameters, which is basically chlorophyll A. So we can estimate chlorophyll A using these ANNs, predict eutrophication events, and also did some sensitivity analysis about the Eastern Mediterranean region. Moreover, we did some work with sea surface current modeling, where we implemented a system that estimates sea surface current in the Eastern Mediterranean at very fine granularity. And the idea here was to use the AIS data coming from the ships to estimate the sea currents in the places where at the routes of the specific ships. So as far as impact, this is what we promised at the beginning, to have a strong impact on efficiency, safety, and the environment. And all the things I presented before shows that we achieved a significant impact in each of these three areas. I should emphasize here also an effort that has been made in the last few years in the area of maritime informatics. So we were able to, together with Michael Lind, Robert Ward, and Richard Watson, we were able to produce two books, the first books on maritime informatics. And this is a collective effort by practitioners, by both practitioners and researchers, with the aim to improve the efficiency, sustainability, safety, and resilience of shipping. So a lot of people are involved in this effort. A lot of them are inside this crowd as well. And I would like to thank them for that. And there's a lot more to come. So in case you did not have a chance to have a look at these books, I would strongly recommend that you do. A lot of interesting information. As far as conclusions, the STEAM project was able to contribute in each of the 5 areas that I mentioned. And in this way, we were able to upgrade the maritime significance of Cyprus. So we improved the efficiency of the port operations by using the Port CDM, the Perseus platform, optimized sea traffic navigation with the Limassol Shore Center. We collected real-time environmental information. We ensured high-quality data and KPIs and created new data decision support tools and services, and developed effective synergies between the stakeholders. And this is a picture from the final event because, like I emphasized at the beginning, this was a group effort. I was privileged to be the coordinator of this effort, and I have to say that I'm very impressed of the results achieved, and I'm hoping for a continuation. So thank you very much.
Thank you, Dr. Michaelides. We have one question for you, please. What is the current adaptation of the various STEAM products and services by the maritime industry? Are there any future plans for their further exploitation?
Yes. A lot of those projects were just a proof of concept type solution, so we didn't really have the chance to test it. And so the adaptation for those remains low since we didn't have a chance to test further. But others are very much ready, like the Perseus platform by Marine Traffic, or the Tototheo platform, the TM Synergia, are already adapted by multiple stakeholders. So those we wish to further expand to other port stakeholders and other users. And we can do this again through, I mean, for me, it would be through additional funding. So we need to secure money for more projects and further developments. But I'm sure there are other ways as well. Thank you.
Okay,